Hello everyone, welcome back to Mtale TV. My name is Robert Mtale and I'll be your pure physics tutor. Alright, so in today's video we're going to learn the topic moments. Then at the end of the topic we're going to have an exam practice whereby we will answer one question from this topic which is in the past paper. Alright, so without any further ado, let's start the topic. Alright, so let's start with the basic definition. As always, let's start with the basic definition. So a moment is a turning effect of the force about a pivot. It is represented by the symbol, and this SI unit is the Newton meter. More specifically, the moment of the force about a pivot is the product of the force and the perpendicular distance from the pivot to the line of action, that force. The formula is moments is equals to force times what? Distance, where F is the force and D is the perpendicular distance. There are two important conditions attached to that distance. First, it must be measured from the pivot to the force, and it must be at the right angles to the direction of the what? Of the force. Please don't forget that important conditions for distance. Number one, it must be measured from the pivot to the force. Then it must be at right angles to the direction of the force. Alright, so that distinction matters a lot, because whether a force is actually produce a moment depends entirely on its direction relative to the distance. When the force is perpendicular to the bar, there is a moment, and the force is able to produce a turning effect. But when the force acts in the same direction as the distance from the pivot, there is no moment at all, because a force pointing straight along the line cannot cause any turning. Alright, now let's look at the principle of moments. The principle of what? Moments. So the principle states that for a body in equilibrium, the sum of the clockwise moments about a point is equal to the sum of anti-clockwise moments about that same point. So this gives us the relationship total anti-clockwise moment equals to total clockwise moment, or written for two single forces. Moment 1 is equals to moment 2, which expands to F1 times D1 time is equals to F2 times D2. So this principle shows consistently in every life. You see it every day. It explains why we can open or close a door, why a pair of scissors is able to cut, and why a seesaw balances two people of different weights, and why a wheelbarrow makes it easy to lift heavy load. So in every one of these cases, the balance or the turning effect being produced comes down to the force acting at different distance from the pivot. It is also worth noticing that why a mechanic always reaches for a larger spanner rather than a shorter one when applying to a loosened stubborn nut. Since moment equals to a force multiplied by the perpendicular distance, increasing that distance even while applying the same force produces a greater turning effect. This is exactly why extra length on a tool gives you extra turning power for the same amount of effort. Finally, the principle of moment is also used to determine the mass of an object, such as a uniform ruler or a plank, when it is balanced on a pivot. So to use this method correctly, there are few things to keep in mind. The weight of the body always acts through its center of gravity. For a body with a uniform cross section, that center of gravity lies exactly at its mid point. This means that for something like a uniform meter rule, its own weight can be treated as a single force acting downward from its midpoint, and that weight can then be included in moments equation alongside any other loads placed on the rule, allowing you to balance clockwise and anti-clockwise moments to solve a problem for unknown mass or unknown distance. And that brings us to the end of moments. Alright, now let's start our exam practice on the topic moment. So this question came in the 2025 GCE Pure Physics paper 2, question number 4, and it reads: Figure 4.1 shows a spanner called the mole wrench being used to unscrew a nut from a bolt. The average force applied to the mole wrench is 20 newtons. Question A1 reads: define a moment of force. Alright, so in this lesson we have already defined what a moment of force is. We defined the moment of force to be the turning effect of a force about what? A pivot. Alright, now we move on to question A2. So question A2 asks us calculate the moment if the 20 Newton force is applied 10 centimeters from the center of the pivot. Alright, so we know the formula. We have learned what the formula is for moment. We have learned that moment is equals to force times perpendicular what? Distance. This will give us force times 0.30, because we have converted y 0.30 because we have converted that 10 centimeters into meters. Always convert your calculation, your distance into what? Meters, please. So when you convert that 30 centimeters into 30 into meters, you simply divide it by what? By 100, which will give us 0.30 meters. Alright, so we're going to multiply that 20 with that figure I've got, then we're going to get 6.0 Newton watt meters, our answer on question A2. Then we move on to question B. Question 4B. Question 4B asks us the nut could not unscrew when the 20 Newton force was applied at the position shown in figure 4.1. Suggest 2 changes that should be made to increase the moment. Alright, so we have learned that to increase the moment, number 1, you need to increase the distance between the point where the force is applied and the center of poverty. Number 2, we have learned that to increase the moment, you need to increase the force applied to the what? To the mole wrench. Then question C, 4C asks us which type of simple machine is the mole wrench. Now we haven't learned this because simple machine is a topic on its own, which will be our next video tomorrow. So here, this is a free mark. I'll just give you the answer. Is what? The lever. Alright, thank you for watching. I hope you have learned 1 or 2 things. Please do watch the following ad.